Hello friends, in today's question, the position vector r of a particle of mass m is given by the following equation. R of t is equal to alpha t cube I plus beta t square j, where alpha is 10 by 3 and beta is 5 and m is 0.1 kg. At t is equal to 1 second, which of the following statements are true? So these are 4 statements and we are going to find out which of them will be true. So let us take for the statement 1, in which we are supposed to prove or find out what is the velocity of the particle. So we have statement A, and we have to find out velocity. So we can say velocity is the time derivative of position vector rt. Therefore we can say, write it in the form of the formula, that v of t will be equal to d upon dt of rt. So we get this as d of dt, and rt is given as alpha t cube r unit vector plus beta t square j unit vector. So we get vt will be equal to 3 alpha t square I unit vector plus 2 beta t j unit vector, and we are given that alpha is equal to 10 by 3 and beta is equal to 5. So if we substitute the value, we get v of t is equal to 3 into 10 by 3. We have t square I unit vector plus 2 into 5 and t j unit vector. 3 goes with 3, so we get vt is equal to 10 t square I plus 10 t j, and we have to find out what will be velocity at time t is equal to 1 second. So we can say velocity at t is equal to 1 will be equal to 10 whole square I plus 10 multiplied by 1 j. Therefore we get velocity at t is equal to 1 will be equal to 10 I plus 10 j meter per second. So which is statement A. So you can say statement A is true. You can write A is true. Now in the second, we have to find out the angular momentum, and angular momentum is your, you can say, cross product of r with v and multiply by the mass. So let us first of all find out statement B. So we have that r of t, which is given as alpha t cube I plus beta t square j. Substituting value of alpha and beta as 10 by 3 and 5 and time is equal to 1 second. So we can say that alpha r at time 1 second will be equal to 10 by 3 multiplied by 1 cube I plus beta is 5 multiplied by 1 square j. So we can write that our r at t 1 second, sorry, r t is equal to 1 second will be equal to 10 by 3 I plus 5j. And the angular momentum, which we are supposed to find out about the origin, angular momentum L with respect to origin will be equal to L at time t is equal to 1 will be equal to mass, and this is position vector r at t is equal to 1 cross product velocity at t is equal to 1. So we get angular momentum t is equal to 1, mass is given as 0.1, and position vector we already found out is 10 by 3i plus 5j, and we have cross product velocity at time t equal to 1 second we already know is part A, that is 10i plus 10j. So this comes as 10i plus 10j. So we can write this will be equal to 0.1, and this comes as 100k divided by 3, and this will be minus 50k unit vector, and this will be equal to minus 5 by 3 k unit vector. Yeah. So therefore we get that angular momentum at t is equal to 1 about origin with respect to origin is equal to minus 5 by 3 k unit vector. So which is our statement B. Okay, it is given that the angular momentum with respect to origin is minus 5 by 3 k unit vector. So statement B is also true. You can see B is true. Now let us solve for option number C, in which we are supposed to find out the force. So we can say for statement C, we are supposed to find out force, and force we know is mass into acceleration. So let us first of all find out acceleration, and then we are going to find out the force. So you can say acceleration of the particle, let us suppose is given as a of t, which will be equal to derivative of v of t, or we also say double derivative of position vector r of t. We already know velocity, so we get acceleration will be equal to d upon dt, and velocity is our 3 alpha t square plus 2 beta t, sorry, here is I and this is j. So double derivative, sorry, the derivative of this will be equal to 6 alpha t I plus 2 beta j. So acceleration at t is equal to 1, so we get here acceleration at t is equal to 1 second will be equal to 6 alpha is 10 by 3 multiplied by 1 I plus 2 beta is 5 and j. So this comes as 2. So we get that acceleration at t equal 1 will be equal to 20I plus 10J. So we got the acceleration. Now we are going to find out the force. So we can say force F at t equal 1 second will be equal to mass multiplied by acceleration at t equal to 1 second. So we get force at t equal to 1 second, mass is given as 0.1, and this is our 20I plus 10J. So we get force at t equal to 1 second will be equal to 2I plus J. And in C it is given that force is I plus 2J, which is wrong. So means statement C is false. C is false. And in the last part we are supposed to find out the torque. Statement D, and statement D we are supposed to find out torque, that torque with respect to origin. Torque with respect to origin, that is torque at time t is equal to 1 is equal to R t is equal to 1 cross F at t is equal to 1. So we can say torque t is equal to 1, we already know that R at t is equal to 1 will be our 10 by 3 I plus 5J cross, and force we just calculated is 2I plus J. So we get this as torque at t equal to 1 will be equal to 10 by 3K minus 10K, and which comes as minus 20 by 3K. So the torque at t equal to 1 second is minus 20 upon 3 K unit vector and Newton meter. So which is statement number D. So D is also true. So from all the options available to us, only statement C is false. So this is false, and rest of the statements are true. A is true, B is true, C is false, whereas D is also true. Therefore, we can write it here that statement A, B and D, these are true, whereas statement C is false. So this completes the question. Thank you.